final presentation before the coffee break. So, and we have 2 more colleagues from AdGuard speaking, actually a duo this time. And this talk will be titled Inside AGLint version 4, a developer, contributor, and user perspective on linting Adblock filters. And we will have on the stage Elizaveta Egofova, who is a front-end developer for AdGuard Web. And her journey started in 2022 as a filter maintainer. And nowadays she's working on the front end. And she's accompanied by Dávid Tóth, who's also actually a repeat presenter at our summit, which is great. And yeah, he's a senior software developer at AdGuard as well. And their conversation or talk will be looking at the evolution of AGLint, a powerful linting tool for app blocking filters.
So, hi everyone. My name is Lisa, and I'm a filter list maintainer as well as AGLint contributor. Today, I'm really excited to talk about AGLint version 4, a specialized linter for Adblock filter lists. I'll focus on how the improvements in AGLint version 4 help maintainers like me, from rule writing and debugging to using the new APIs and benefiting from performance boosts. Together with David, we'll show how AGLint supports both casual users and advanced contributors.
Hi everyone, it's great to be here again and see so many familiar faces. My name is David, I'm from Hungary, and I work for AdGuard in the extensions team. We've been working hard on a full rewrite of this tool, and in this talk we walk you through the major updates and the motivation behind them. Let's begin with a quick introduction.
So here's how our presentation will look like. First, we'll give a quick introduction to AGLint, what it is and why it matters, just to make sure everyone has the right context, even if you have never used it before. Next, we'll walk you through the new features in AGLint version 4 and show a couple of practical examples so you can see the improvements in action. Finally, we'll share a short outlook on what's coming next, the ideas and plans we are working on future of AGLint.
And just to note, we didn't plan this talk to be technical. So no worries, it should be easy to follow whenever you are a developer, a filter maintainer, or just curious about the ecosystem.
So let's quickly look at what AGLint actually is and why it matters.
Essentially, AGLint is a linter for Adblock filter lists. It scans the rules, highlights problems, and suggests fixes. The main goal is to help maintainers to produce higher quality filter lists that are more reliable and easier to maintain. AGLint is not just a command line tool. It also integrates into popular editors like Visual Studio Code. That means you get real-time feedback as you write or edit rules, with syntax highlighting, autocomplete, and instant linting built right into your workflow. On the screenshot, you can see what the colors are representing in the logo. Its concepts are inspired by ESLint, a popular linter for JavaScript.
AGLint is designed for different kinds of users, depending on their needs and level of involvement. For most maintainers, it's very simple. Just install and initialize the config file and you're all set. You can also use it via VS Code extension. With that, you get things like syntax highlighting and built-in tools all right in your editor, with no extra setup needed.
Some of our more experienced users would prefer a bit more flexibility. For them, AGLint provides a plugin API, so you can use it to create custom rules, adjusting existing configurations, or extend the linter for specific workflow. And now it's time to talk about the new AGLint features.
These slides give a quick overview of the most important improvements introduced in AGLint version 4. We won't dive into all of this just yet. This is more of a teaser. you'll see that we've completely rewritten the core engine to make it faster and more flexible. We've added new APIs for autofixing and suggestions, introduced caching to skip unchanged files, and improved the CLI and editor integration for a smoother experience. There are also several new and redesigned linter rules that make it easier to catch common issues. We'll go through each of these areas in more detail in the upcoming slides.
The biggest change in AGLint version 4 happened under the hood. We completely rewrote the engine. From now on, the engine allows efficient management of parsers and querying of the data structure using selectors. This provides much more flexible solution, both for the core's internal implementations and for the linter rules. We'll talk about this in more detail on the next 2 slides. This rewrite also made the engine more flexible. It now supports debugging mode, caching, and the refined autofix and suggestion API. It also lays the groundwork for a future plugin system. Finally, we have put more emphasis on web support. While this already existed in earlier versions, our roadmap now includes deeper integration with web-based editors. This opens the door to better integrations and faster feedback, even without needing a full development setup. In the next few slides, we'll demonstrate the basic operation of the core through a very simple example. We don't intend to go deep into technical details, and we wouldn't have time for that anyway, but we'd still like to give the audience a general sense of context. So, the very first step is parsing the filter lists into what's called an abstract syntax tree, or simply just AST. The AST is essentially a structured object that represents the elements of the source code, in this case, the filter list. With the new engine, this process is much more efficient and allows us to use even more parsers efficiently. The importance of the other parsers becomes apparent in cases like this. By default, for example, we parse modifiers, network rule modifiers, for example, as key value pairs. But the value itself is not further parsed by the main parser. However, in the linter, we need to parse that value as well in some cases.
For instance, in the example shown on the slide, we need to parse a pipe-separated domain list, and the engine provides a way to do that. You can see a simple network rule, and below it, an illustration that shows how the AST should be imagined. In reality, the structure is a bit more complex, but the main idea can be clearly seen in this example. The key point is that the network rule is broken down so that we can identify the pattern, see which modifiers are used, and what values they have. In this example, the a.spacecom domain will be considered invalid in the linter because it contains a space. By the way, we have a 2-panel AST Explorer that allows you to view the AST of any filter list in interactive, user-friendly, and well-organized way. We've also included a link to it on the slides, and we will show it in demo.
Yes.
Yeah. The second step is loading the linter rules. Linter rules are essentially structured in a way that they define CSS-like selectors, which allow us to target specific parts of the AST. These selectors are then linked to so-called handler functions, which determine what should happen when the corresponding nodes in the AST are reached. When we reach a domain node, its value, the domain, is validated by a function. In the function deems the domain value, if the function deems the domain invalid, the linter rule reports the issue back to the core. Otherwise, if everything is fine, we simply continue processing.
The API is made up of 2 main parts. Meta holds rule information like type, description, or any other details. And create The create function runs when the linter rule is initialized. Within this function, you can return selectors and their corresponding handlers. Essentially, they are selectors to which we can attach a handler. For example, if we want to access the body of element hiding cosmetic rules, we simply specify element hiding rule body node type and assign some handler to it.
Let's start with a bit of context. In our GitHub setup, AGLint runs automatically on every commit. This happens through CI. That's great for catching issues early because it used to be quite wasteful. Most commits only touch a single file, maybe 2 or 3. It's very rare that someone changes more than 5 files at once. But before caching, the linter will still process the entire repository, every single file, even if 99% of them hadn't changed. As the project grew, this starts to slow things down noticeably.
And let's talk about the solution. In AGLint version 4, we introduced a caching mechanism. Now, the linter keeps track of previously linted files and their content checksums. If a file has not changed since the last run, we just skip it. Only files that were modified in the current commit are linted. Local linting has been significantly improved thanks to caching. When cached, the process now takes only 66 milliseconds on average, a major speed up compared to the older runs. In a single-threaded setup, linting takes around 2.5 seconds, but with multi-threading that drops to 1 second, more than twice as fast. These optimizations make development much more smoother and more efficient for filter maintainers.
This change is especially helpful for filter maintainers working on large lists. They get faster feedback, and CI pipelines don't bottleneck as the project scales. It's one of those things you don't necessarily see, but you definitely feel the difference. So another one key change. When we set up AGLint in a new project, we quickly run into lots of small issues, like naming, formatting, and rule changes. These weren't hard, but AGLint couldn't fix them automatically, so we had to do it all manually. It was slow and easy to make mistakes. And after setup, every time AGLint updated with new rules or changes, we got even more issues. These were mostly small fixes, but without automation, it took a lot of time to clean them up.
Let's now talk about one of the most user-facing improvements in AGLint version 4. How we help users fix problems in their filter lists. Sometimes when the linter detects an issue, there is a clear and safe way to fix it. In those cases, we can just apply the fix automatically. But other times, the situation is a bit more complex. Maybe there are multiple valid fixes, or it just depends on the user preference. That's why AGLint now provides 2 types of fixing APIs. One for auto fixes and one for suggestions, where the user makes the final decision. They work together to improve the developer and maintainer experience, both in the CLI and in your code editor. On the next 2 slides, we'll look at each of these APIs in more detail.
This flow helps compare autofix and suggestions APIs. Both start the same way. The linter finds an issue. Then the key question is, can this fix be applied safely? If yes, we use autofix. The change is done automatically, no extra work for the developer. If no, or if there are multiple possible fixes, then we use suggestions. The linter explains the options and the developer decides. So autofix is about speed and automation, when suggestions are about guidance and choice.
Autofix is all about safety. If the linter is confident that the fix is safe, it just does it for you. It's great for low-risk issues like formatting, quoting, or other simple rule patterns. It works seamlessly whether you are in a terminal or using a code editor.
This slide shows an example of when we can use autofix. On macOS keyboards, it's easy to type curly quotes without noticing. Curly quotes do not follow the style guide and can make the rule invalid. AdGuard syntax only accepts straight quotes, single or double. In the first version, curly quotes are used around a prune and product ads. It's a scriptlet name and a scriptlet argument. The corrected version replaces them with straight double quotes, and the rule works as expected. This type of fix is safe because it doesn't change the meaning of the rule. It only replaces curly quotes with straight ones. Curly quotes are never valid, so autofix can always correct them without risk of breaking the rule.
Suggestions are there to guide rather than decide. In situations where the linter can confidently pick a single fix, or where the user preference makes a difference, it does not try to force a choice. Instead, it offers one or more possible fixes. This is essentially useful when multiple valid options exist. For example, the rule might be technically correct in more than one form, but it's up to the maintainer to decide which style they prefer. The Suggestions API gives you that flexibility. The best part is that these suggestions are directly integrated into your editor UI, like VS Code. So instead of looking at cryptic warnings, you get a familiar code action menu, click, choose the suggestion you like, and move on. It's all about keeping the user in control, while still providing enough guidance so you don't have to figure out everything out on your own.
This is an interesting case. In CSS styles, the same property can sometimes be written more than once. Let's think about when we can use autofix and when we can use suggestions. In the first situation, both the property and its value are exactly the same. On the slide, you might see the same line repeated twice. In this case, it is safe to remove one of them because the duplicate does not change anything, so we can use autofix. The second situation is different. The property is the same, but the values are not. Here, the linter cannot guess which value the user really wants. Therefore, in this case, suggestion is more appropriate. The user should decide which one to keep.
We have some sync issue. We support non-pseudo classes like not, has, or extended ones like contains. But sometimes users write something unsupported like foo. The tricky part is typos. For example, contains, almost contains, probably means contains. A linter can be 100% sure, but if we find something invalid, we can do a fuzzy search and suggest likely matches. According to what you see on this slide, it's contains a typo can be suggested to fix as contains, because most likely user mean contains. They just made some mistake. And in the second case, probably fuzzy search does not find a similar result to foo. So if the fuzzy search algorithm does not find anything from the known names, we should offer removing the pseudo class. However, probably it breaks the selector, so it's not safe, and we can just offer as a suggestion. And this idea is not limited just to pseudo classes. We could apply it to modifiers, scriptlets, and more.
So I want to talk about compatibility tables. The tables are essentially YAML files containing information about scriptlets, modifiers, redirects for each Adblock syntax, along with APIs for interacting with this data. They serve as compatibility references that let us quickly check whether a specific modifier, redirect, or scriptlet exists. This helps developer avoid guesswork and ensures consistent behavior across syntaxes. The tables should be always updated as new features are added. To keep them accurate and complete, we invite you to contribute. Your input helps improve the reliability of these compatibility resources. Now compatibility tables is part of AG tree, so you can check our repo at this URL filter.
And just to mention quickly, autofix and suggestions are built right into the CLI as well. That means when you run linter locally, you can not only see the issues, but also apply safe fixes directly without leaving your normal workflow.
And one more thing about configuration, it is important to check rules for the correct syntax. This is especially useful when we work with third-party filters or with different blocker syntaxes. Rules can be written with mixed syntax, which creates inconsistency. By setting the syntax directly, we can convert rules for the same format. On this slide, you can see part of the configuration that set preferred syntax to AdGuard format.
Now it's time to talk about the planned AGLint features.
Our next focus is on expanding the rule set to make filtering more flexible and powerful. We need your help to vote on, create, and update rules. You can join us on our GitHub repo. We don't want to do this alone. We're looking for inputs and ideas from filter maintainers who deal with real-world use cases every day. Your feedback will help us shape smarter, easier-to-use filtering rules for everyone.
Next, we plan to integrate these features into the user rules editor, so it's easier to customize and extend linting rules without touching the core code. We're also exploring formatting support. It's still a question mark, but the idea is bring consistency to code style in addition to linting. And finally, we want to create a GitHub action for the marketplace that would wrap everything, autofix, caching, even opening pull requests or issues automatically, so teams can drop it into their CI pipeline with almost no setup.
Thank you very much for your attention. We want to demonstrate some demo, and after that we will be happy to answer all your questions.
Okay. So, for example, we have a linter rule which checks the number of selectors in a selector list. And you can see here we're using 2 selectors within the selector list. And linter shows the error message that this rule contains 2 selectors, but only 1 selector is allowed. And we have the quick fix option. And actually, we have 2 options here. One is just disabling the linter rule if we want to keep these 2 selectors. And the second one is fixing the problem. And I just click on it, and it splits the rule into 2 rules, and one of them all of them contains just 1 selector. But for example, I can choose the disabling rule, and and in this case, it keeps the 2 selectors in the single rule. And here you see the same. Sometimes we have parsing errors. So basically we have 3 types of errors. First is the fatal error, when something parsing error happened. In this case, we can't investigate the AST in more detail. The second one is error, and the third one is just some warnings. You can change the rule severity in your configuration between warning and error, but fatal errors only can be thrown by the core. And here is the fuzzy search. You can see here a selector which wanted to be has text, but there is a typo in it. And if I go to the quick fix, it offers me to change it to has text. And if I click on it, it just changes it. It's done by fuzzy search from a set which contains all the known pseudo classes. We have modifier validation and some excluding rules. It's useful, for example, in AdGuard filters repo. And we have some additional rules like CSS duplicated properties. In this case, we have two exactly same property, same value, same key, and same value. In this case, it's safe to apply an autofix because they are the same. So I just choose the fix, and the second one is disappear. But in the second rule, you see there are two color properties, but with different values. So in this case, the linter is not able to decide which one the user wants to keep. So in this case, if you click on Quick Fix, it offers you two suggestions: remove the blue or remove the red. And I remove the blue, and it just keep the red. Also, we have some validation for values. It's based on the CSS3 database, which is, as I remember correctly, based on the MDN database. And the same also works for uBlock syntax too. So all the syntaxes are supported. It's still under development. We plan to release it in the near future. But as you can see, it's already in a so-called alpha beta stage. So that's it. Thank you for your audience.
Well, amazing progress. Congratulations.
Thank you.
I was wondering if you already parse all the rules to an AST and you support multiple dialects. Would it be possible for you to easily transform one dialect to another? Yes. Let's say from Adler to uBlock.
Yes.
Good. That's great. Thank you.
We plan to integrate the converter.
That's fantastic. Cannot wait.
Hi, thank you for the presentation. I was wondering if you ran the linting tool in a CI pipeline, and if so, how do you manage the caching feature that you explained that you can do locally?
Yeah, there is an option for example, in GitHub. There is an existing mechanism to store the cache. There is a official action extension from the GitHub. And it's also possible on Bitbucket, for example. So it's a little bit up to the user. We mainly dealing with GitHub in this case. And as far as I know, most of the filter lists are maintained on GitHub. And it's possible easily on GitHub.
So then the hash from the file is somehow stored in GitHub?
We have a...
That's how the files that have no changes get skipped and then it gets faster.
Yes, we have a AGLint cache file, and this contains the hash of the files and the hash of the config of the linter. Because if anything changes, we should run the linter again. And we have two caching mechanisms. One is for file metadata, like when the file modified, and the file size. But some cases we need the content hashing because, for example, Git does not keep the last modified time. But in 99% cases, just the meta will be enough.
Cool. Thanks.
Very cool progress. Thank you. Are you familiar with Code Mirror? Are you familiar with Code Mirror?
Code Mirror?
Yeah.
We have a user rules editor, right, for Code Mirror. Actually, I more went into the direction of Monaco. We experimented with Code Mirror too. By the way, we have just an interesting of matter. we have this AST Explorer. Can we bring back this screen, please? Thank you. I forgot to show it, sorry. And actually here you can have a two panels view, and it's based on CodeMirror, by the way.
I see. Okay, so it does work already in CodeMirror.
And here you can debug the AST.
Gotcha. Very cool. Thank you.
Hey, so thanks for the talk. So I was wondering if you expose a generic language server for integration with any editor, or do you focus mostly on integration with VS Code?
Actually, the AGLint itself is, of course, editor independent. We have a language server, which is based on VS Code, but I think it's quite easily can be transferred to any other editor. But basically, we support VS Code and want to integrate to the user rules editor. Not sure we want to support anything else.
Awesome, thank you.
Nice. Okay, thank you, you two. You definitely wowed some in the audience, as it seems.